Welcome to sitza.com.
Cannizzaro reaction. Aldehydes which do not contain any alpha hydrogen atom, when treated with the concentrated alkaline solution, they undergo the disproportionation reaction, means they undergo the self-oxidation and reduction. So we have here a formaldehyde. It does not have any alpha hydrogen atom. In our last lesson we learned, what is the alpha hydrogen? If you have a carbonyl group and the adjacent carbon to this carbonyl group is alpha carbon, and the hydrogen atoms attached to this will be called as alpha hydrogen. So that means this molecule has got alpha hydrogen atoms, right? For the Cannizzaro reaction, what we need, what is the condition? The condition is that you should have aldehyde without any alpha hydrogen atom. So we have a formaldehyde, it does not have any alpha hydrogen atom. Alright, because if you have alpha hydrogen atom, the molecule can undergo aldol condensation, that we have learned in our last lesson, right, in our previous video. So here we're going to discuss only about the Cannizzaro reaction. So Cannizzaro reaction is the reaction of aldehydes which do not contain any alpha hydrogen atom, right? When you react with them, the concentrated alkaline solution, right? So concentrated potassium hydroxide, KOH. So what you will get? One of the molecule will be actually oxidized and another molecule will be reduced. We know aldehydes, when you oxidize them, what you will get? You get a carboxylic acid, right? So you get a carboxylic acid. One molecule is oxidized to the carboxylic acid. Another aldehyde molecule is reduced to the alcohols. So that's why you get two molecules here. One is alcohol, the other one is carboxylic acid. So that means in a Cannizzaro reaction, if you have two aldehyde molecules, you can, react the aldehyde molecules without any alpha hydrogen atom with a concentrated alkali. So one molecule is oxidized, another molecule is reduced. Now let's look at the mechanism. How does this reaction actually take place, right? So let's write down the mechanism of this reaction. In the mechanism, the first step here is aldehyde without any alpha hydrogen atom. Okay, let's say the formaldehyde. Okay, when you react with a concentrated alkali, it is the hydroxide ion which actually attacks on this carbonyl carbon, and the electron pair shifts like this, and what you get? You get now a carbon with the O negative, and this carbon has got two hydrogen atoms. Okay, already it has two hydrogens, and now it has a one OH group. Alright, now in the next step, what's going to happen? Another aldehyde molecule, you'll take another aldehyde molecule without any alpha hydrogen atom. Okay, now from here, one of the electron as H negative shifts, and that acts as a nucleophile, attacks on the carbon, and this electron pair shifts here. Okay, so this is what you call as a hydride shift, right? This is called as a hydride shift. Very important step in this one, right? Okay, so hydride shift. So H negative actually is transferred, right? H negative is transferred from this compound, from this intermediate to the another aldehyde molecule. So now this particular carbon will have a carbon with oxygen negative charge, and it has two hydrogens, right? It has got two hydrogens, but it also has a one more hydrogen from here. So that's why I'm going to take the color code a little bit like this to show that this hydrogen is coming from this aldehyde molecule, right? Okay, this intermediate compound. So that is a hydride shift. First is the attack of a nucleophile, then second step is from the same aldehyde molecule, now hydride shift will take place to another molecule, and you get this molecule. Now what is this one? You can say it will pick up a proton from the water, right? So normally first it forms a salt, potassium salt, and then, okay, let me take it up, okay, positive here. Okay, so then what is the other product that you expect, right? After the hydride shift, what you are left with this from this molecule, right? From here, what you have? You have a carbon, and this electron pair, it will go down when the hydride shift takes place. Electron pair goes down, forms a double bond with the carbon, so you get a hydrogen, carbon, double bond oxygen, and then you have a OH. Alright, so now you have in a reaction mixture, you got a carboxylic acid, right? You got a carboxylic acid, and you got an alcohol, right? This is an alcohol here, correct? So now what's going to happen in this reaction mixture? You have a carboxylic acid with the acidic proton. So that means what will happen now? Now there will be the proton transfer, right? there will be the transfer of this potassium here and hydrogen to here, right? So alcohol will be like this. You get a carbon, OH, and it has got three hydrogen atoms. Now this is an alcohol, and this carboxylic acid will be now the salt of a carboxylic acid, right? Potassium salt, right? Okay, you have a K positive here. Now you get a potassium salt. Alright, so that means in the Cannizzaro reaction, you get one alcohol, one carboxylic acid. And the important step in the mechanism is hydride shift, right? H negative. Hydrogen with electron pair shifts from one aldehyde to another, aldehyde molecule, right? So let's take one more example here in the Cannizzaro reaction. If you have a benzaldehyde, again you can see in the benzaldehyde, this is the alpha carbon, right? Okay, and it does not have any hydrogen atoms, right? It does not have any alpha hydrogen atoms, so it can undergo the Cannizzaro reaction. Benzaldehyde cannot undergo the aldol condensation. We have learned in the aldol condensation you need alpha hydrogen atoms, right? So aldehydes and the ketones having alpha hydrogen atom can undergo the aldol condensation. But right now we are talking about Cannizzaro reaction. For the Cannizzaro reaction, you need a carbonyl group without any alpha hydrogen atom. So if you take a benzaldehyde molecule and you're going to react with the concentrated alkaline solution, let's say the potassium hydroxide, okay, so what you will get, one of the aldehyde molecule will be oxidized. That means you get a carboxylic acid, a salt of a carboxylic acid here, okay, this is C double bond O K positive, and you get another molecule will be converted into the alcohol, that will be reduced from aldehyde to the alcohol. So you get a benzene molecule, right? You have a benzene ring here, and that is attached with the CH2OH. Okay, so this is the alcohol that you get. That means if you take a benzaldehyde molecule, treat with a concentrated alkali, potassium hydroxide, one molecule will be oxidized to the salt of a carboxylic acid, and another molecule is reduced to the alcohol. Okay, so let me take another example. Let's check whether this molecule can undergo the Cannizzaro reaction or not. Suppose you got a carbon attached with the CH3, H, and C double bond OH. Now, what about this molecule? Can this molecule undergo the Cannizzaro reaction? Can it show the Cannizzaro reaction? No. If you react with a concentrated potassium hydroxide, it cannot undergo the Cannizzaro reaction. Rather, it will undergo the aldol condensation, right? Why? Because it has alpha hydrogen. This is our alpha carbon, right? This is the alpha carbon, and the hydrogen atom attached to it is an alpha hydrogen atom, right? So it has alpha hydrogen atom, so that means this molecule cannot undergo the Cannizzaro reaction. Okay, so rather what will this molecule undergo? It can show the aldol condensation, right? Not the Cannizzaro reaction. Correct. And in the aldol condensation, we learned, what are the products you get there, right? There is a condensation, right? Two molecules condense. So we have a separate video on that. That means if you take another molecule, like this, C double bond OH, and you got alpha carbon, it should be attached with the three other carbons, right? If it's attached with the other three carbons, now this particular alpha carbon does not have any alpha hydrogen atom. There is no alpha hydrogen atom now, and therefore, if it does not have any alpha hydrogen atom, then you can say that the molecule can show the the Cannizzaro reaction if you react with the concentrated potassium hydroxide. Okay, it will undergo the Cannizzaro reaction, right? Depends on what is the other structure. It can be CH3, it can be CH3, or this can be C2H5, whatever it is, right? So, but the point is, this alpha carbon does not have any hydrogen atom attached to it. Does not have an alpha hydrogen atom, so it can show the Cannizzaro reaction. Alright, the condition is that molecule without alpha hydrogen atoms, when treated with the concentrated potassium hydroxides, can undergo the Cannizzaro reaction. Hope you got the concept. Thanks for watching the video. Bye for now.